Just recently, we built our own AI server, and it's made out of enterprise equipment, it's expensive, it's large, and it now sits in a 4U enclosure in our server rack. And it generates quite a bit of noise. This right here is a new AI supercomputer. It's a supercomputer in its performance, but it's clearly very much a mini box. This is AI Top Atom. It is based on Nvidia Spark, but with GIGABYTE's special sauce. We'll put some chapters in so you can skip to the area that you're most interested in. We'll test it out, unbox it, and then go through the basics that you can get with this machine, and then get into deeper testing in the next video. We're going to have it as a multiple part series, so there'll be additional things that we can test it out, so don't forget to comment down below. Let's open up and see what we've got inside. We have the machine itself, and if you thought the box is small, look at the size of this bad boy. It is actually tiny. It's basically the size of a small book. It is quite heavy though, so this is around 1.3 kilos, so it's very sizable in your hands. And inside we have a power supply. It's a Delta power supply, a 240 watts, and it's using the USB-C connector. And we have a little power cable. That's it, that's all you get. It's all about the little AI box on the table. Let's have a look. So we have a cool grill on the front. I actually kind of really like it. Then on the side we have a Kensington lock, and on the back we have a power button. We have a power connector for the Type-C, and then we have 3 USB-Cs. So this is using USB 3.2 and then all 20 gigabit. We have a HDMI 2.1 as well as a 10 gigabit LAN. And then we also have ConnectX 7. So you can use these for just general data as a normal network card, or you can actually use these to daisy chain multiple of these machines. So you can actually buy 2 or 3 of these and stack them together to get a lot more performance, which would be insane, but I feel that some people might do it. So who is this actually for? You set it up with whatever AI software you use, and you use it as a development machine. So you might have a developer with their own laptop or PC that they work on, and they will most likely connect to it via the network and have it just sit somewhere in the corner, running its own thing, minding its own business, and processing your AI workloads, whether it's generating pictures, like memes. You know, if you buy this machine making memes, a bit sad, but what you can really do is use it in your own development. So since you would have this machine in-house, you could literally have it on your desk, you can connect all your models and work in a private way. You don't have to send your data elsewhere, you have a lot less latency, but main impact here is privacy. Your data is with you and you control it fully. So you can tweak the models, you can do whatever you actually desire yourself, and we'll play around with that a bit later on. Let's talk about specs. This machine comes in a few different variants. This is a decked out version which has 4 terabyte NVMe SSD inside. So it's the full speed, full storage, and it comes in at $4,000 US. So it's really expensive, especially if you count it by weight. It's really expensive machine. AMD has also released basically a direct competitor to this back in January. It is their Strix Halo product, and it's also using the 128 gigabytes of unified memory, so it could be used for basically the same things for the same way. Well, it's not quite the same way. AMD's machine is very price competitive, but it's missing one core component, and that's Nvidia. Most developers out there, ever since the beginning of developing AI, have been using Nvidia software stack on Nvidia's hardware. And they're so far ahead now and so integrated into the whole ecosystem. Basically, people get taught in most cases to start with Nvidia, and then now it's becoming a bit more competitive with different brands coming into the market. But the baseline, kind of the core, is Nvidia. So being able to develop and have your own machine with your own computational power using CUDA or Tensor cores all in one place is exactly what this is about. Its ability to have your own piece of developing hardware or mini server on your desk and use Nvidia stack to run whatever you desire. This is obviously not for gamers. What this is very useful for is those maybe startup developers or companies that need local performance, that don't want to be sending off their data, or somebody who's developing. I've actually seen from our previous videos some comments of people creating their own, using the models to go through their own customer emails they send to them and prioritize their work, and basically having somebody, which is an AI machine, help process some of the workload to kind of pre-digest the workload that's coming in and sort it out in such a way that a person then can sift through for quotes, for work, and get organized that way. I think that's a really cool use case. It's something that you'd probably have to buy once for a considerable amount of time, and it will be over time producing you value and probably some, tinkering that somebody's gonna like, but it's gonna produce value over time that you're probably gonna get your money back within X amount of time, obviously depending what value it's bringing you. So let's set it up and see what we can actually do with it. Well, I've already found the first issue with it, and it's, well, USB-Cs, and most people have keyboards and mice that use USB-As. So I had to get a dongle out and plug it in. So it's all plugged in. Let's see how it boots. Yep, GIGABYTE. We have things happening. So it comes pre-installed with DGX Linux version. So it's Nvidia's own version of a Linux, which has tools and optimizations. And also Nvidia actually has a huge amount of guides online where you can literally copy and paste commands or scripts to start developing almost immediately. It's a very, I'd say, very user-friendly, especially for somebody like myself who is not really a developer, but I like to tinker, and it helps you get it set up. While it's booting, let's talk about specs themselves. So we have 128 gigabytes of unified LPDDR5X memory. In this machine, you have 4 terabytes of SSD, 20-core ARM CPU. It's based on Nvidia Blackwell chip. For communication, we have Wi-Fi 7, 10 gigabytes of LAN, as mentioned before, Bluetooth 5.4. We have 4 total of USB 3.2 Type-Cs, and obviously the Connect X7 NIC, which is using 2 QSFP network connectors. Welcome to AI Top Atom. Let's set up your new personal AI supercomputer. Now, after the update, you just basically log in and you're inside the OS. It looks like a normal Linux. What we need to do now is download GIGABYTE's special source, which is their own utility. So for that, just going to go Google AI Top Atom, and there should be normally the top result. And what you want to see is the one that has the little support button over here. So just go to support, and you download the latest utility. They've actually recently updated it, so there's extra features and kind of known fixes. But I assume this is going to be updated on a more regular basis. So you download that, and then you go to your files. And you just need to get it installed. It even comes with a little manual as well, so the installation process will take a little while. It's around 400 megs. It's not too big, but it's still sizable enough. I think it's probably going to be downloading extra components. Yeah, it looks like it's doing extra bits. So it's not as simple as just click and go, but look, it's Linux. You're not going to have everything in just double click, but once this is installed, we'll be able to open up the little dashboard. The app actually took a while to install. Not because it was slow to install itself, but actually it was a long time to download it. And that's why we've actually went ahead and plugged in a network cable. Moving forward, at least have a wired connection, which could be way faster. So once it's been installed, just select your language, got your standard terms and conditions. And here we go, we have our dashboard, we have the GPU and a CPU load, so you can actually see on the fly temperatures, even DRAM loading. We have the total available DRAM, which is 120 gigabytes. And we have the NVMe storage, which is actually funny. It's not recognizing the SSD amount right now. So we'll look at fixing that a bit later on. From here, we can go ahead and go to download models. And for downloading models, what you want to do is actually add in your Hugging Face access token. For that, there's loads of guides online how to generate one. Go through one of those guides, get the token and add it in here. I'm just going to download a bunch of models one by one so we can get into testing them out and seeing how this machine delivers. I wish GIGABYTE made it a bit easier where you could just pre-select and add them to queue, so you would just download over time, because again, a lot of models are big, and since this machine can support larger models in one go, you're more likely to download the 50 or 60 gigabyte models for your testing. So I wish they improved that. So I'm gonna feed that back to GIGABYTE's team to just see if they can make it scheduled rather than just having to wait for one to download and then go after the other. Just downloaded two models. One of them is GBT-OSS and the other one is Llama 4 Scout. So the GBT-OSS is the 20 billion parameter model. So it's not too big. It's what you would probably use on a normal graphics card, something with about 12 to 16 gigabytes of VRAM. On the other hand, this 61 gigabyte file will not fit within any normal graphics card. You need to go enterprise or start merging multiple graphics cards at the same time. So what we're going to do, we're going to go into the Inference. So these have been downloaded to the home admin model folder. So we're going to go to Inference, and the tool that's set up here is basically you can select your inference type. So text to text, text to image. What this means is, I think they're probably going to have a good example here, but basically we're going to put in text in our little text dialog and we'll receive text back, such as normal responses like you would have from ChatGPT. Or if you wanted to go text to video, as long as your model supports it, you would request it to create you a video of a kitten or on a fence or whatever else, and you'll get a video of that. So you need to have the right model for that. So in this case, we're going to test GBT-OSS 20 billion, which is going to be the text to text. Here, what we'll do is we need to select the actual location for the file. So home, model, and there you go. We're in here. I think just a folder. There you go. What it does, it's actually, you can see here, it loaded the file. Offload is basically how much GPU and CPU we want to provide to the model. I'm going to just max it all out. And for the tokens, so you need to know, depending on your model you're using, what the maximum amount is. So we can actually select for GBT-OSS is actually 131,000. But I'm just going to do a 32,000 amount just for the sake of the argument now. 32,768. So for top here, we're going to use something like about halfway through. And for temperature, I actually prefer using 1. But for those who know, they know how to adjust this, and it affects basically the accuracy and the creativity of the particular model. And then you basically set start, you will load the model and set the parameters, and then you'll be able to communicate with the model and actually do your AI inference. We've actually got some tests we can use just for the sake of testing it out and see what the performance we're going to have. So let's do something like this. So prompt 3, A3, just going to dump that into the question. Let's go. As you can see here, it's going through and providing output. And it just goes on and on as it's supposed to. If we look on the left, we actually see that the CPU is basically not even being used at all, which is a good thing. CPU is actually slower than the GPU in this example, so you want to utilize that Nvidia chip to do the processing rather than offloading to the ARM CPU. And the actual amount of data coming through is a lot. It's not the fastest. I believe I've had faster performance on a 3090, but you know, 3090 is a dedicated large card. This is actually absolutely silent. It has warmed up a little bit. It's no longer cold, definitely warmed up, but it's completely silent. So what we've got out is 5,040 tokens, and the tokens per second is just over 50, so 50.83. Let's do something bigger. So I'm gonna request it to do a larger output. I want to see how far we can push it. I'm going to start a new chat. So I'm going to stop and start a new chat. One thing you see here is you are not really seeing like a memory or like a history of your chats. For that, you're going to have to use other utilities. But generally speaking, developers are not using an app like this. They would actually be doing it straight out of command line. And let's let it run. That's going to take a little while, so we can go through. You can see in memory here, when it finished the task, it actually drops down. That's when we stopped the chat. So it actually cleared its memory. And once we started the chat again, it picked up the memory again. And now it's running through the actual inference. But the memory is not climbing up because ultimately the size of the node is already loaded in there. It doesn't need to go and load a lot more data. the data will increase. So if you go and talk to the model over and over, the amount of memory you use will go up. So that would make sense. But I don't believe these particular conversations are that large. Obviously, I can repeat the same thing over and over and over and get to like insane length, but let's leave it running. The second task is complete and we've got around 53 tokens per second. Pretty good. You can also use Inference on mobile. So what it does, it opens up a QR code. You can actually scan this with your phone and it just opens up a web page for it. And you can just ask questions. And it sends through the request straight to the server. So I'm remotely connecting now to the server and getting the data out of it. And it's just on your mobile. Yeah, and you can do exactly the same thing from another machine on your network, which is very convenient. So you can actually run this as a box and just ask it questions. As long as you load up the model on the machine itself, you're good to go. Gigabyte definitely provides you an easy enough tool to control it remotely and have it set up with just clicks of the button rather than having to go through manuals and type in any code and whatnot. Let's do one more task and test out a bigger model. So I'm going to load it up. So I'm going to stop chat. Once you've stopped it, you can select a different folder. So it'll again ask you to navigate to the folder you want to go to. We'll select Llama and load it up. So what we should see is, you see we've cleared up the memory. That should take a lot longer now to load up, and this memory should go way up. It's definitely taking way longer because it's literally moving this now from SSD. So you can see right here, the SSD is going overdrive to between 2 and 2.5 gigabytes per second. There you go, it's loaded. Memory's up. Not as much as I expected actually. That memory should have been way up there now. Apparently it's only using 15 gigabytes. That's a little strange to me. Well, let's ask a question. I'll just ask the same question. And here I'm expecting the answer to be a lot slower because it's a much bigger model. It's going to do way more thinking and it just takes a considerably longer time to process that. As you can see, it's pumping that information out way slower. And for now, we actually see the CPU is definitely using up a lot more. And the fan kicked in. I can hear the fan now. So we're going to do a very unreasonable test where it's right in front of us. It's about 42 decibel right in front of it. And we're talking, this is like 20 centimeters away. So very reasonable for where you are. I'm a little surprised that the memory is not showing properly here, but I guess, yep, that's because the Linux system is not showing proper details. There you go. So we can actually see here, our DRAM usage is actually 72 gigabytes. That's what you would expect from this. And that's why we can see that the temperatures have gone up as well. Temperatures around 60 on the GPU core. And I am a little bit puzzled why GPU is not processing this inference. All the processing is happening right now on the CPU. I'm wondering if it's the tracking details or is it just the way that this particular model works. Yep. There you go, it's finally finished. So it took way longer, but we have our results. So evaluation tokens around 1900 and tokens per second were 6. Way slower. And lastly, let's just open up another chat. And what I want to do here is actually do text to video. I'm going to offload this model. We'll do text to video and we'll select a model. So we'll use this one here. We'll do length of video of 3 seconds. Let's do 6 seconds. 720 by 480. And we'll see 8 FPS, just for testing. Let's see what this does. Go straight to the dashboard. I wish that Gigabyte created a dashboard that could be just placed on the side so I can be seeing my stats at the same time as going through and using the chat. So I think there's a few things they could improve. So I can actually see that it's using the GPU now and it's using around 25 gigabytes of memory, which is about right for this size of the model. Let's see, it's created it's still creating it. It's already at 6%, so it is progressing. Within here, you also have, we can go to your general settings. You can go through and change your language settings. So we've been only testing out the inference. You also have RAG, where you can utilize existing information, whether it's pictures or any other known quality items, and then embed that into the data that you're using, which is the model. So for example, you can actually include your own data, such as database of your previous jobs, your general database, or maybe even a wiki page on information that you have. You can give that to the model to reference, and then it will use the model itself plus that data to provide users with relevant information. It's very useful for basically finding relevant topics or answering questions in Q&As. It's very useful for something like including a full wiki into the LLM, and then within the company, users might have a question that they want to have clarification on how to do something, and if something that they're doing is the right approach to it, and maybe even utilize the processes further. So they could potentially input their data that they want to process, and using LLM, something like this, you can actually reference the kind of documents and standard operating procedures and output the delivered project, which is a very good and effective way to improve efficiency within the business. Also, it speeds up kind of training of new staff or what's relevant within the business. It's not simple to just spend months training a user. With something like this, you can actually just give them the tools, and the tools will train the person along the way. All you need to do is train them on how to use AI tools efficiently and safely, because AI still makes things up. So you need to be careful with that. Let's see how it's delivering the video. So it's most likely saving the clip right now. There we go. So we got ourselves a cat. Let's see what kind of clip is it. That is definitely a cat. It may look a little bit, the animation might not be the best, but it looks like a cat on, it looks like a cat in the fence. That looks like it's not necessarily the, it's kind of sitting in front of the fence, isn't it? Or in the middle of somewhere, and then, yeah. Look, it's an AI generated video. So overall, I've got to say, somebody who just picked up one of these machines probably would be very keen on just getting out of the box and start using it immediately. And GIGABYTE has done a good job at creating a tool that is somewhat easy to get used to and at least start playing with the device that you just bought. You know, you spend $4,000, you want to be able to use it immediately, not necessarily learn all the ins and outs. Professionals will probably ignore all of this and go straight into developing like they would. But there are a few things I would like GIGABYTE to improve. I would love for the dashboard to be available more the side, maybe like some sort of pop-up that you can just select and move to the side so you can just track your metrics. Also, it's an easier way to see if your model actually works properly, if it's being offloaded to the GPU or is it running on CPU only, or maybe you have some sort of a bottleneck. That's kind of an important thing to see. The other thing I'd love GIGABYTE to improve is the downloads. Clicking once and waiting for the model to download and then clicking again. I wish you could just go and download 4, 5, maybe even schedule 8 of them. That's exactly what I did on my server. And then just, you know, it's going to take a little while to download. You know, set it up to download and go for a break. Get some coffee, come back, and then use it. I think if they did a few of these little tweaks, some of it is visual, some of it is clearly some serious programming to do, I think it would be an excellent tool to start off your journey. But other than that, I'm going to get deeper into testing this machine. How about you let us know what you think about the machine and what would you like us to test on it? Look, it's a mighty small machine that can do a lot, clearly, and I really want to push it much harder than this. The fact that it has 128 gigabytes of unified memory means that it can load models that I couldn't load before. This may not be the fastest machine in the world, but it has plenty of memory and it can load big models to process. So as long as I can just wait for the results, this is really awesome. So let us know in the comments below what you would like to see. Other than that, if you want to check out more about this machine, we'll leave a link down below. As always, don't forget to like this video and subscribe for more.